Hi, this is Tom Reardon, math teacher from Ohio. I want to show you how I use TI-Nspire activities in the mathematics classroom. Today we're going to look at vertex and factored form of a quadratic using the TI-Nspire CX handheld. This is one of over 1,000 activities at that website. The following are two quadratic equations in vertex form. The first one with numbers in it, the second one is the generic AHK or vertex form, as sometimes we call that. We want our students to understand how changing the values of the parameters for either A, H, or K affect the graph and see those patterns there. So our students are going to investigate this using the TI-Nspire CX handheld. Now, this is the old way. This is how I taught for many, many years. I would spend an entire period of the class having my students graph y equals x squared, y equals x squared plus 1, y equals x squared plus 2, y equals x squared minus 1. And we would graph them, we'd make a table, we'd do all those things. And by the time we had done about 6 of them, I would ask them, do they see a pattern? And usually, after doing that took 30 minutes, they lost what we were trying to get, okay? It just took too long to get there. So the new way is with TI-Nspire, we can use something called sliders to be able to have students investigate what all the parameters do. So this is that one. Let me bring it up. I'm using an emulator, the TI SmartView emulator for TI-Nspire. And so I'm going to be using this on an interactive whiteboard, but the students would be doing this on his or her own individual handhelds. So it says examine the effects of parameters on the vertex and determine which form to use when solving problems. So I'll advance to the next page. And here is the graph of y equals x minus 2, the quantity squared, plus 1. And you'll notice that the vertex is drawn out in blue to kind of make you pay attention to that a little bit better. And these are sliders right here that enable the student to change the values of those parameters and watch what happens to the equation and to the graph simultaneously. Now, the first one normally we look at is the K one, the one that is the vertical shift. So just kind of showing you, the students would be asked to press this, K equals 2, K equals 3, K equals 4, K equals 5. And they can see that the graph is shifting up as K increases. And as K decreases, they see that in the equation, they see it in the graph, and even K can be negative numbers. Now, in a matter of a minute, I've now accomplished more than sometimes it took me almost a half or a whole period to do by hand. Students see it, and I keep their attention. Plus, they're not watching me, they're doing it themselves. Similarly, let me go ahead and pull this back up a little bit. I can also look at the H parameter, the one inside the quantity squared. And so as I increase H, x minus 3, the quantity squared, x minus 4, you can see that the graph is shifting to the right. And as H decreases, it is shifting to the left. Here it's at the vertex is at negative 1, 0, y equals x plus 1, the quantity squared, plus 0. And again, after doing this for about a minute, the student gets it, understands what the horizontal shift is and how that's affected in the equation. And then finally, let me go ahead and move this one back a little bit. I can also look at the coefficient, the A value, and see if I increase A, how that makes the parabola narrower, because it's going up faster. And then I can also decrease the value of A, and you can see how that makes the parabola wider. Now I'm going to go down to 0. 0 is kind of a silly one here. We just get the graph y equals 0, or the x-axis. But for negative values, you can see that the curve now opens downwards, and as the absolute value of A gets larger, the graph gets narrower. And these 3 parameters are now being investigated all singly in the same period, and we've not been able to do that easily by hand before. And not only that, we can now investigate combinations of them. For example, if I have y equals negative 1/2 times the quantity x minus 1 squared plus 0, what happens if I increase K to 1? To 2, to 3. What happens if I make H decrease to 0, to negative 1, and so on? And then what happens if I make the value for A increase again? So now I can look at 3 parameters and how they're affected, or 2, or a combination of them, and investigate that. Students are making their own generalizations, they're creating their own learning, and they're all working at their own pace on their own handhelds. much better than the old way. The second part of this is looking at quadratic equations in factored form. And here I have a specific example and then a generic example. I'm using R and S as the roots here, and A is that coefficient again. And we want them to understand how changing the value of A and R and S affect the graph and what that looks like in the equation. So here again, I'll go back to the next page, control right arrow. And here I have the graph of y equals 1 times the quantity x minus 2 times x minus 5. Those are the two factors. And if I increase the value, let's say, of, or decrease the value, let's say, of r to say 1, 0, -1, we're hoping that students will notice that this value here, the x minus -1 and the x minus 5, those are the zeros or the roots of the equation. And we would like them to be able to see that. I can change the value of s, and again they can start to see patterns here. And then I can also do the same thing with changing the value for a, how that makes the graph narrower if it's increased, and if it's decreased, how it makes the graph wider. So students can see there's definitely a relationship between having an equation in factored form and seeing the roots, and having an equation in vertex form and seeing where the vertex is and where the graph translates. And this, what we've done, can be done in a single period, and this is not something I ever would have tried in a single period, both of these things at the same time. Just did not have the time to be able to do that. It took too long. Plus it took a long time just to graph equations like this by hand. To summarize here, one of the things I like about this activity is that students discover the math and create their own learning, their own understanding. Okay, they're doing it at their own pace. And also students are able to investigate, look for patterns and generalize, and they're working in groups, they're helping each other, they're communicating good mathematics. Here again, just some screenshots here, how powerful this is as a teaching tool, showing the vertex in the top two, showing the zeros of the quadratic right there, and how it opens wide, narrow, whatever. And again, just as a reminder, you get these at the Math-Inspired website. This would be an example showing the objectives and also showing how it correlates to the Common Core state standards, how to download them, standards alignment, textbook alignment, everything's right there for you. So I hope you enjoyed our presentation today, and thanks for watching the video.